Hello, today we're going to talk about the association between numerical variables. So when we observe the relationship between two variables, we normally use a scatter plot to visualize the trend of the data. So the relationship or the association between two variables is what we call the correlation. There are five things that we consider when we describe the correlation between two variables. We describe the direction, linearity of the data set, the strength, the outliers, and causation. So let's talk about direction and linearity. So direction means that we want to figure out whether our data is trending in a positive direction or a negative direction. All right. So the first scatter plot here, our direction here will be a positive linear relationship or positive linear correlation. The second scatter plot is what we call a negative linear correlation because it's going down from left to right. Positive goes up from left to right, negative goes down from left to right. If we look at the third scatter plot, this is going to be a positive nonlinear correlation. Linear correlation, linear data sets, they look like a line. If it doesn't look like a straight line to be drawn, then that is what we call a nonlinear correlation. Then next, the fourth scatter plot, we can't tell what direction this goes in. So because it looks like it's just random, we consider this no correlation. So now let's talk about strength. The strength of a correlation describes how closely a data set follows a trend or a pattern. So the strength normally falls in one of three categories. We normally consider correlation strong, moderate, or weak. Okay, so if we look at the top graphs here, the top three graphs, we will see that the first graph on the left is what we consider a strong positive correlation. The middle top graph is what we call a moderate positive correlation. And then the last graph at the top is what we call a weak positive correlation. Notice when we say strong, moderate, and weak, you should be able to look at the way the data points fit around the line that is drawn there. The closer your points are together to form a straight line, the stronger it is. The more spread out your points are from each other, the weaker it is. All right, so just like the top row of graphs, the bottom row of graphs on the left will be a strong negative correlation. The lines are tight, the points are tight, around that line, and it is going in a negative direction. It's going down from left to right. The middle one is a moderate negative correlation. And the last graph is a weak negative correlation. All right, so now let's talk about outliers. So outliers are points that are not in alignment with the trend of the majority of the data. If an outlier is the result of a measurement or graphing error, it should be removed from the graph and the data set. If an outlier is a factual piece of data or an authentic piece of data, it should be kept. Next, we're going to talk about causality. So before we even do that, let's go back to the outliers. What I mean by outlier is you may end up seeing like a point that is far off from the rest of the points, like this blue point here. This will be considered an outlier. Okay, so you can see that it is basically not in alignment with the rest of the majority of the points. All right, so causality. It says correlation between two variables does not always mean that one variable actually causes the other. Okay, if a change in one variable causes a change in another variable, then we will call it what we call a causal relationship. Okay, so just because you may feel like there's a correlation between two variables, it doesn't mean necessarily that one variable actually causes another variable or a change in another variable. It could be that they both relate to a third variable, which in turn makes them related to each other, but it's not the actual causing factor, okay, in the relationship. All right, so if you have any questions on association between variables, please let me know and have a great day.